Alpine ski racing involves a lot of vectors, as it uses physics laws to get down a course as fast as possible.
First of all, the objective is to go around some gates which are represented by the points A, B, C, and D in the following graph. In order to do so, the body and the skis act as vectors. This picture shows vectors of opposite direction. The red one is positive as it represents the velocity as I get down the hill, versus the blue one is negative because it represents the work of friction that goes against velocity. The blue vector represents the force I exert on the ground, while the red vector represents the normal going against this force. As they are both equal and going in opposite directions, they result in a null vector permitting me to stay put. The blue vector is also a 2D normal vector in regards to the line the ground makes under me. Here, both of my skis act as parallel vectors. All red, blue, and yellow vectors are plus-minus vectors as they go in plus direction, either in X or in Y, and in the other direction, they go in the minus direction. We can also see that if we add the red and the blue vector together, we result in the yellow vector, or if we subtract the blue vector from the yellow vector, we result in the red vector. We can also do a dot product with the red and the blue vectors, which will result in a certain number. Here my skier is represented by the vector -8, -1, and the unit vector, which is a vector in the same direction as the vector represented by the ski, but of magnitude of 1, was computed above. This isn't a picture of myself, but we can see that the skier's right leg acts as a 3D orthogonal vector as it goes perpendicularly between the Y, the X, and the Z axis. Here we can see that gravity is represented by the red vector. As we are in a hill, so there's an angle, gravity is subdivided in Y and in X. The Y of gravity is the orthogonal projection of the red vector, and the X of gravity is the parallel projection of gravity. I hope that this video helped you understand the vectors in skiing and that you found it interesting.